Hello everyone. So in the past couple of videos, we've been learning about multiplexers. In this video, let's see how we can solve the following problem. So the question says, how can you use a 4-to-1 multiplexer to implement the following Boolean expression? And then the requirement is to use C and D as select inputs for the multiplexer. So it says draw complete circuit diagram. So feel free to pause the video and try to take an attempt on your own, see if you can solve it. So the first step is we need to start from the truth table. So C and D are our select inputs. So we'll have here the C and D, and then the output is always to the left of any Boolean expression, which is F. So for two select inputs, we have four possible combinations: 0, 0, 0, 1, 1, 0, and 1, 1. So now let's see what will be passed for every single combination of these, starting by 0, 0. So let's take this Boolean expression. Okay, so let's see for when C is 0 and D is 0, what we will pass to the output F. So this will be equal to, so C is 0, C prime is 1, and D prime is 1. So the first term will be A, plus, from this term here, D is 0, so this is going to be gone. And also similarly here, this term will be gone. So when C is 0 and D is 0, F, we will pass A to the output F. Next, let's see when C is 0 and D is 1. So F will be equal to, so C prime will be 1, and D prime will be 0. So this term will be gone because D prime is 0. The second term here, C prime is 1 and D is 1. So we will have B. The last term here, A prime, C is 0, so this will be gone. So from the second row, we will pass B to the output. Now let's see the third row, it's the third combination. When C is 1 and D is 0. So let's write the whole thing. For the first term, we have A multiplied by C prime is 0. So we don't have to worry about this will be gone. Plus, second term, we have B multiplied by C prime. C is 1, so C prime is 0. Also, this will be gone. Plus, last term, we have A prime multiplied by C. C is 1 in this row, multiplied by D. D is 0, so this will be gone. So in this case, we will pass 0 to the output. Now let's see the last case, when C is 1 and D is 1. So this will be equal to A multiplied by C is 1, so C prime is 0. So this will be gone. Plus B multiplied by C is 1, so C prime is 0. So this will be gone. We don't have to look at the rest. Plus the last term, we have A prime multiplied by C is 1, multiplied by D is 1. So multiplied by 1, multiplied by 1. So this will be equal to A prime. So from this case, we will pass A prime to the output. Okay, so now we can draw the circuit for our 4-to-1 multiplexer using this truth table. So now this will be 4-to-1 MUX. We have four inputs. We have two select lines. Those are C and D. And we have one output, which is F in this case. And this is 4 cross 1 MUX. Now on these here, so when C is 0 and D is 0, we will pass A. So we have A. For 0, 1, we have B. Third, we have 0, so this is a ground. And then lastly, we have A prime. So we have A here, right? So we can use a NOT gate. And this is A. So we can bring A from here. So we'll have A prime on this side. So about the internal circuit of this MUX, so we can use this Boolean expression to draw it. So we need an OR gate. The output is F. And then since we have three turns, we need three AND gates. This is 1, 2, and third. So our select lines, we have C and D. And then we can get C prime by using a NOT gate. Now we can just connect everything. For the first AND gate, we need A, and then we need C prime and D prime. So this is C prime and D prime. For the second AND gate, we need B. So this is B. We need C prime and D. So this is C prime we can take from here, and D we can take from here. And then for the third AND gate, we need A prime, C, D. So this is A, we get A prime on this side, and then C, D we can take them from here. So this is C, and this is D. So this is how we can solve this problem. I hope this was helpful. Thanks for watching.
Enjoyed this video? Subscribe to the Computer Engineering Notebook for more tutorials on computer architecture, embedded systems, and hardware design. And hit the bell to catch the next one.